Hello and welcome back to Coding Game. The last time we were doing Coding Game was the spring challenge? Wait, we can find out here. What was it? Past events. Oh, I didn't do this one. Because this was not bot challenge. This was like a interview style questions. I wasn't interested. It was this one. The Fiverr. Oh, the athletics thing. But this was when? When was this? Beginning of the year. Yeah. Oh, it was June. Okay. Alright, well, yeah. So we've got the 4 challenge to do now. This one is not a bot programming challenge. It's an optimization challenge, which is interesting because they don't do many optimization challenges. They haven't done many in the past. Bot programming has always been the most popular, but it's nice to change things up. It won't be as competitive. Well, it's still competitive. It's still a leaderboard. But it won't be directly competitive in the sense that you're not actually pitting your bots against other people. You're just seeing who can get the best score. What does 100% mean? Probably 100% is like whoever's at the top, and then, well, whatever. We'll find out soon enough. I don't even know what is going on here. So, let's read. No, exit. The project is now official. Selenia City, the first city on the moon, will be inaugurated in 2050. Oh, are we appearing here? Yay! We're featured. The definitive layout of the city hasn't been fully determined yet, so the architects are looking for a solution that could best adapt to all possible configurations. After your victory in the planetary programming games, you were the first to be called to design the artificial intelligence that will develop the first transportation network on the moon. Okay, I like the sound of this so far. The game is played in 20 lunar months of 20 days each. What's a lunar month exactly? It's not an Earth month, is it? Or is an Earth month a lunar month? So an Earth month is the time it takes for the moon to go round. Maybe that's also what a lunar month is? Oh, it isn't. It is the month. Our month is a lunar month. That's what a month is. Okay. Hello, DJ. All phases of the moon is lunar month. Oh, okay. So I guess it doesn't actually sync up perfectly with the Gregorian calendar, but well, according to this, it's 20 days. But we're playing it as 20 days. At the beginning of each month, you will receive resources as well as the list of new buildings constructed in Selenia City. You will then need to use your resources efficiently to connect the new buildings to the network or reinforce the existing infrastructure. There are 2 transportation modes on the lunar base: magnetic tubes and teleporters. Magnetic tubes. Magnetic tubes are built on the lunar ground and allow transport pods to carry astronauts through them. They are built in a straight line between 2 buildings and are bidirectional. The tubes cannot cross each other, and each building can only be connected to at most 5 connected tubes. A magnetic tube cannot pass through a building without stopping them. Islam uses lunar month, which is why Ramadan wanders around in the Gregorian calendar. Oh yeah, of course. All right. Initially, each tube can only accommodate a single pod at a time, which takes an entire day to travel through it, regardless of its length, while carrying a maximum of 10 passengers. It is, however, possible to upgrade tubes so they can be traversed by several pods simultaneously. Each building can only be connected to 5 magnetic tubes. I don't think we're working on a grid here as such. I guess you can have tubes going in different directions, other than just up, down, left, right. You will have the possibility to configure precisely the path of each transport pod, which can travel freely through the network of tubes. Teleporters. Teleporters provide a very efficient way of traveling, although they are more expensive to build than tubes. They allow astronauts to move instantly from a building to another, without limits on how many passengers can use it at once. The path of 2 teleporters can cross. Since replication equipment is very bulky, each building can only accommodate a teleporter entrance or exit. Buildings in Selenia City are organized in a rectangular area of 160 by 90 kilometers. 2 types of buildings will exist in the city: lunar modules and landing pads. It's quite a lot to read here. Actually, it's not too bad compared to some of the bot programming challenges. Lunar modules. There are several different types of lunar modules. Laboratory, ground sampling site, observatory. Okay, this is like a full RTS game. That will, well, not RTS, like city builder game that will permanently house the astronauts. You will need to transport each astronaut to a building of the corresponding type in order to win points. So that the type of module, the only thing that matters really is where an astronaut wants to go, I guess. There may exist several modules of the same type in Selenia City. Landing pads. Landing pads are buildings that work in a special way. At the beginning of each month, a rocket will drop a group of astronauts on each of them. The composition of the group is fixed. If, for example, a landing pad welcomes 5 lab technicians and 10 observatory employees, an identical group will arrive each month. If several lunar modules have the same type as the astronaut, he may settle into any of them. Oh, so lab technicians would want to go to the lab. These guys would want to go to the observatory. Okay. Your solution will score more points if it manages to balance the astronaut population well between modules of the same type. Okay. Your objective is to score as many points as possible before the end of the simulation. Each astronaut reaching its target before the end of the lunar month will give you up to 100 points. The speed, 50 points, from which are deducted the number of days needed by the astronaut to reach the destination. For balancing the population, 50 points, from which are deducted the number of astronauts who have already reached the same module during the current lunar month. If it's negative, the score will be brought back to 0. Wait, so can speed go negative? Can you lose points if you take way too long? maybe. Wait, so I thought we'd be building the transportation networks, or maybe we are. I don't know, or maybe we're just choosing a route, in which case it's more pathfinding, but... Okay, let's read more. Alright, implementation. Each lunar month happens in 4 stages. City parsing. At the beginning of each month, your code receives information about new constructions in Selenia City. Okay, that's a lot of stuff. It's describing resources, routes, so like tubes and teleporters. Pods that are in the tubes. Buildings, new buildings. So we need to keep track of the old buildings as well. Alright. Your code can then transform the city through actions that allow you to build and improve its transportation network. Oh man, this is tough. But that's optimization for you. There's no easy solution. Just try to do the best you can. There's no leagues here either. So you're allowed to build a tube. Upgrade a tube. You need to spend the initial construction cost multiplied by the new capacity to upgrade it. So to build a tube, you're paying like X, depending on the distance, I guess. Yeah. To upgrade it, you would then pay a further 2x. Upgrade it again, you'd pay a further 3x. So the cost goes up. Well, linearly, I guess. But that's still quite a lot. Teleporter. Build a teleporter. 5,000. It costs 5,000 to build a teleporter. A tube will cost 1 per 0.1 kilometers. So like 10 per kilometer. Right. Okay. You can create a pod. Oh good, city planner games are notoriously easier. This definitely already looks more complicated than stuff like SimCity or... What's the city planner that's actually Surviving Mars? That's probably the closest thing to this kind of theme. Surviving Mars is a good game. It had some flaws though. I don't think it was a very scalable game. Like once you get to big cities, it's just you're still just doing the annoying micromanagement thing for all the little things. It's just it didn't scale well. There's other games which kind of where you can scale to big cities better, but I think Surviving Mars it just like it just doesn't feel like a game where you can go build massive cities. I don't know if you were meant to, but I might give Surviving Mars another go. They may have improved the game since I last played it. Okay, astronaut movement. In real life, city planning doesn't scale well because people are people. Yeah, that's true. But I think some games do a better job of it in the sense that the little micro optimizations you have to do are made redundant because then you build like, I don't know, tier 3 of a certain thing where you don't have to worry as much about micromanaging. So like as you progress, you sort of don't have to worry about the stupid little things like controlling the number of employees for a certain building or something, and can allow stuff to kind of automate itself as you get bigger and bigger. I don't think that was really as present in surviving Mars, especially as the game didn't warn you when you're running out of resources or whether a certain thing is failing or power is running out and stuff like that until it's too late. Yeah, that's the other thing. I don't think it had good like metrics and graphs which kind of give you an indication of what's going on in your Mars, in your planet. But it had a good theme though, and there was I don't know if there was a story, but I think there is one now. I think back when I played it, there was no real point to the game, no real objective. Because one thing you had to keep micromanaging is the types of people you welcome to Mars. And once you get into the hundreds, thousands of people, it gets a bit fiddly because the filters, they have filters like saying you want educated or you want children or whatever, but it's still a lot of manual configuring. You want people who don't drink too much alcohol or things like this. You have to really and you still have to handpick the people a lot of the time. Alright, astronaut movement. This isn't going to be a long stream. I just wanted to do like a bare bones implementation. That might get me a few points, and then we'll do more next time, but looks like I'm going to spend most of the time reading this. Astronaut movement. Once all modifications have been applied to the transport network, 20 days will happen during which astronauts move within the network autonomously towards their target modules. Okay, so all this happens on the first day, basically, or in 0 time. You are told what has changed in your city. You make transformations to your city. I assume that just happens instantaneously. I think so. And then the 20 days of the month happen in which your astronauts move day by day. We've only got 6 days for this, so it's quite a short thing. I suppose even though it seems like there's a lot of reading, because you're not actually competing directly bot versus bot, you're not actually writing AI. So that I guess makes sense to have it shorter because it isn't as complex, even if it may seem more complex. When you eliminate AI, it becomes easier. Traversing a magnetic tube always takes 1 day, regardless of the distance. Interesting. So it's good to have long tubes, I guess. On a given network, we can then define the distance from one building to another as the minimum number of tubes needed to make the entire trip. So you want to minimize changes rather than distance. That's usually how I plan my train routes. Changing trains is always the most complex bit. I'm happy to spend another hour sitting on the train if it reduces the number of changes I need to make. So you want to minimize number. Okay, fine. So this is, in mathematics terms, this is the there's a type of metric that refers to this. Everything is distance 1 from each other. Metric spaces, simple examples. this one here. Well, they haven't given it a name. Discrete metric. Ah, here, discrete metric. Everything's distance 1 from each other. Okay. Astronauts plan their route in a naive way by trying to move towards their nearest target module. Ah, so we don't... Wait, do we plan their route for them? No. Oh, so they choose the routes. Ah. So we're just... we're placing the routes. We're placing the mechanisms that they can use for their routes. They choose the routes, but they're not going to use a complex pathfinding. They're going to use this naive algorithm, and this is, I guess, the core of the whole challenge, really. By trying to move towards the nearest target module, they'll take any tube or teleporter available that takes them closer to their destination, I guess by physical distance in the world, without actually considering the pods scheduled on the following days to determine whether their trajectory is optimal and feasible. Okay. Right, it expands here. So the movement phase happens in 4 steps each day. Teleporters. So if they are standing on a teleporter right now, they will take it if the exit is closer. Less than or equal. Well, it can't be equal because you can't have it in the same place. So if the teleporter takes them closer, then they will unequivocally just take it. Okay, fine. That's that. Allocation of pods in magnetic tubes. It is possible that several pods are trying to move through a tube that has insufficient capacity. In this case, pods with the smallest identifier are given priority, and the others remain in place until the next day. So there's a queuing system, but it's not first come, first served. It's whoever has the lowest ID number. In other words, whoever arrived at the planet earliest, I guess. That's how the IDs are given out, which is reasonable. So it's minimizing the time since arrival. Allocation of astronauts and pods. Each astronaut tries to find a pod with a free seat that will move towards their destination, i.e. takes them somewhere closer, and hops on board. Astronauts choose in order. The astronauts who come from a landing pad with lower identifier pick first. Oh, it's the pods. Because pods have capacity. So the pods with the smallest ID go first. So that's somewhat arbitrary, I guess. But over here, the astronauts who came from a landing pad with a lower ID number. So that's arbitrary as well. You could have 2 pads. One is ID 1, one is ID 2. The ones who came from 1 will get priority. So it's not based on who arrived first. Alright. So starting with the ones with the lowest ID number, the landing pad ID number, they will choose pod. Launch of all pods. Each pod moves towards its next step with its astronauts on board and all passengers disembark. Ah, okay, so there's no... I thought maybe there'd be like walking distance or rover driving distance between pods. So they will only ever be within the teleporter slash tube network. So if it's disconnected, they literally cannot get to their destination. Okay, that makes it easier, because then there's no... I thought maybe they'd walk between two tubes if there's like no actual network between them. Okay. So these are 3 landing pads. They have IDs 2, 3, and 4. On the first day, the red astronauts teleport to Module 6. So there's a teleporter here? It's okay, I don't understand what all the icons are. Buildings 4 and 6 are both 3 tubes away from their destination. I think they could do a better job of explaining what I'm looking at here. Where are the astronauts? So they arrive on those 3... those red dots are the astronauts. Okay. So they're standing at 4. Okay. Teleport to Module 6. How do I know there's a teleporter here? I think from the diagram we don't. Do we? I don't know. So apparently there's a teleporter here. And they use it to go to 6. 4 and 6 are both 3 tubes away from their destination at building 0. They want to go here. Via the discrete metric, as I mentioned before, these are equidistant from 0. And astronauts will always take a teleporter if it does not increase their distance to the target. It's not physical distance, so I was wrong before. It is distance according to the discrete metric. And that's why it can be equal. So they will always take a teleporter if it does not increase their distance. So if a teleporter takes them to a place which is equidistant from their destination, they will take it. Interesting. And that can sometimes be bad. Because there's no real reason to take the teleporter if it's taking you somewhere which is equidistant from your destination, is there? So that's a very naive move, but it does probably get you out of like soft locks, sort of. I don't know. Green astronauts in 3 can move to either 2 or 4 via the tube. Which are both 1 tube away from a green module. So they could go here, here. On the first day, 10 green astronauts take the pod from 3 to 4 due to their naive pathfinding algorithm. Okay. Only to become stranded there until the end of the month because no pod will ever go from 4 to 1. Because the city just we haven't set up a pod from there. Okay, I get it. Oh man, it's growing more and more complex. This is reminding me more of OpenTTD. which is a great transport planning game. It's an open source kind of like remake of Transport Tycoon Deluxe, but it's really well developed. So it's like it can be heavily modded, and you can have lots of people playing multiplayer. But yeah, you can really get into this game to the point that you're writing like differential equations and spreadsheets and stuff to actually optimize your cities and transport networks. Remember that astronauts will only take a pod if it strictly lowers the distance to their target. On day 10, it can be surprising that blue astronauts move from 3 to 4, because both buildings seem to be the same distance away from their target at building 6. The distance from 4 to 6 is actually 0 due to the presence of a teleporter. Ah, teleporters are 0 distance. Okay, fine, that does make sense. So 4 to 6 is 0 distance. This actually means it's not the discrete metric that I mentioned before, because in the discrete metric, you're not allowed to have two things which are different things, but are 0 distance apart. There is a law that says that in metrics, that if two things are distance 0, they are the same thing. Okay, interesting. So 4 and 6 are basically like an equivalency relation. They are the same, effectively the same location, as you can, if you get to either of these places, you can then teleport to the other. Okay, that's that. At the end of each month, all remaining astronauts disappear from the play area. Okay, they just die. They didn't get to their destination, they just die of malnutrition. And all pods immediately return to their starting point. Okay, that makes things convenient. All unused resources yield a 10% interest rounded down. Okay, so you gain interest on resources that you bank. Most 150 buildings will be constructed. So we don't build buildings. The game builds buildings. We only build the networks between them. This is kind of similar to an interview question I had for Amazon when I applied to work at Amazon, but it wasn't just like it wasn't a simple interview question where you have like an hour to write on a whiteboard. No, they actually gave us a laptop, and we had like something like 5-6 hours to churn out a solution. And it was actually quite similar to this, but it was based on drones. So you had a network of shops and factories and warehouses in other words, Amazon. And you want to set up drones and set up the routes they follow in order to try to minimize the amount of time it takes for customers to receive their stuff or whatever, like various metrics. Yeah, it was quite tough. I almost, at one point, I almost walked out because I felt like I was just failing so badly. But then I did actually manage to get a solution. No, well, there's no solution. It was an optimization problem. So you're just trying to get a good score. Well, they hired me, so clearly I didn't completely botch it. That was in Python. Fortunately, because if I was doing it in C++ or something, I would take like 5 times as long. It's not exactly difficult to understand, but there's a lot to sort of process at the same time. I don't think I can do much in like 5 days. This is definitely something I would want like 2 to 3 weeks on. 1 to 100 astronauts each month. 1,000 maximum per month. Buildings don't appear on tube paths. $500 milliseconds per turn. That's quite large compared to bot programming tournaments. Usually you have like a tenth of that, I think, per turn. Tips for getting started. Start by programming your transport pods in a simple way. Moving back and forth on the line is usually quite efficient. Yeah, maybe we do that. That's how most cities work. The identifier of each pod. Oh man, we could recreate the London Underground. So we've got to have like a circle Hammersmith line. Yeah, we've got to have Northern Line, Jubilee Line, Metropolitan Line, Elizabeth, Victoria Line. I mean, I'm only half joking. Like, if you did model it on a real like city like London, for example, you probably would get something that's reasonably effective, because that is the point. That's why the urban planners did it that way. All right, point segment intersection. Oh, this is yeah. This is how you work out if a point is on a line, because you don't do float comparisons, equality checks, so you need an epsilon, and yeah, that's useful. So they've confirmed that on this grid, this epsilon value of that. Normally I would go a little bit higher just for safety, but if they've confirmed that that epsilon value is safe for this grid, then yeah, cool. Segment intersection. No, I wouldn't go higher, I would go lower, but okay. Segment intersection. To verify whether two line segments, or you use in linear algebra, don't you? You do the cross product, the dot product? That looks like the cross product. God. Well, they've spelled it out for us, so I don't have to relearn undergraduate linear algebra again. It wouldn't be the first time I've had to do that for a coding game tournament. And then we've got the game source. Selenia City. Selenia. Is that a reference to anything from like sci-fi video games? Okay. Oh man, I feel overwhelmed now. Because we're gonna spend ages just processing the input. There's a lot. Yeah. Let me just grab a method that I usually use, the logging statement. Log. So if we run our example, does this actually work? Well, it's always going to work, even if you do nothing. You just get a bad score, right? So that's... What's our score? 53,800. Ooh! Doing well. So this code actually does work. The only reason it would fail is if you error it out or something. Wait, what is it doing? Print tube 01, print tube 02. Okay, so it's actually trying to create tubes in invalid places for some of these because these locations don't exist. But that's not going to cause an error. It just gives you a warning. So, oh, villages actually failed. What happened here? Probably those ID numbers don't even exist. By the way, stop. Okay. Oh, you need to score at least a point to pass the test case. Okay. So let's stick with example 1. We've got a landing pad here. We've got blue and we've got green. So this train here is just going back and forth between them. Let's start writing some stuff. Resources. All right, so we're gonna have to store all of this. So, should we create a class for the city that describes the city? And all its buildings. So each turn, they only tell us the new stuff, the new buildings. So we have to remember all the old buildings. So we can't just delete all our memory and create a fresh batch, which is what I usually do. So we want... Do we want this to be a data class? I've almost forgotten how to use data class. It's quite hot. I'm gonna look at some of my old code. I've forgotten how to code. So we use data class like this. So you specify your variables like that, int. So we want a list. Yeah, we could do that. So we want... We do want it frozen. City is like a static. It's like we don't want to... So when we create a data class, we just want to specify. So we want, let's say, buildings is a list. Like that. Is that not how you do it? Yeah, you do. Okay. Is that what we want? A list of coordinates? No, we probably want a hash map. Do we? I don't know. Yeah, because you've got ID numbers, so you want to map ID numbers to the XY coordinates of the building. What else? Resources, I suppose. It's int. So they'll tell us the new resources. We don't have to apply the 10% interest or whatever. Wait, we need to open up the Okay, that's resources. Got that. Non-travel routes. The number of routes currently present in the city. So we should probably just store tubes and teleporters separately. So say tubes. Suppose this will be a set. Because it'll be like a pair. Actually, a tube has properties, so we need description of a tube or teleporter. So describe a pair of IDs and a capacity. Capacity 0 indicates that it's a teleporter. Oh, okay. So teleporters is easy. That would just be a set. There's nothing else you need to know about it. Oh no. Teleporters. It'd just be a set of building pairs. So you'd have if 1 and 2 are connected via teleporter, but it's entrance exit. It's not bidirectional. Then you'd put 1, 2 in the teleporter, but tubes are bidirectional, so you'd put 1, 2 and 2, 1 in the case of that. I mean, tube. Okay. Do sets as well. You just need to store the capacity along with it. Alright, and then you got num pods. Alright, pods. The pod has an ID. It has the path that it's going to follow. Okay. So I guess we can make a class for pods. So as an ID num. And then a path. Or like a tuple, I guess, because it's like not going to change. We're going to get lists because I don't think this, we only get this at the beginning of the month. I think we have to keep track of its path as it moves around. Well, we don't do anything for the month. The month just happens. We only do stuff at the beginning of the month, don't we? Yeah. So we can make that a tuple then. You can destroy pods to get 750 resources back. And you got num new buildings. Okay. So buildings is here, so we have to add the buildings. So building has an ID num, XY coordinates, has number of astronauts, astronaut type. Okay, so we'll need something for this. So it's an ID num. It has position. That be a pos, so we need to actually make a pos class. It's just going to be XY coordinates. Got num astronauts. But okay, so these are not. Well, these are fixed. If there's 5 astronauts, they're saying every month it will be the same 5 astronauts coming. So this is frozen. Okay, so num astronauts, or we don't really need the num. We can just say astronauts is gonna be a tuple of some sort. And it will contain their types. Are those, what are types? Strings, I guess? We'll find out later. Can you actually do this? Like say what you want it to be? I don't think you do that. Alright. Or like this? I don't think you do. So that's a tuple of strings. That is a tuple of... So path is ID numbers, isn't it? Where was I? Yeah, it's ID numbers, so it's going to be tuple of ints. That's going to be... You don't actually need to specify the type of a dict. You're allowed to have multiple different types in it. Well, you're allowed to do that in a tuple as well, but... Okay, well, I guess you can do this. Yeah. So it maps ints to building. Teleporters is a set of it's actually a tuple of pos. Not even that. It's a tuple of ints, but it's going to be a pair of ints. Is it? Wait. Yeah. Tubes is a set of what? It's a set of... So a tube is a pair of ints and a capacity, so it's like it's basically the same as this. Alright, just to be extra. Oh, pause. Let's just copy some code from... We didn't use pauses here. When did we... Winter... What was the winter challenge? Did I not take part in that? What was the winter challenge? Let's have a look. It was another interviewing thing. Oh no, I did take part in it. I have a rank. What was this? Yeah, it was one of those interview things. Oh, these are the oldest ones. The newest ones were this one. Okay. Fall challenge was the last. This was the, oh yeah, that thing. So we got pause. We don't need all these classes, but we can, or all these methods, but we can use some of it. And yeah, I had this idea of a rect and intersections of rects. 600 out of 4,500. Yeah, I did pretty well in that. I think I had a nice idea with a little bit of geometry in it, and what was going on here? Lots of sine. I was pre-computing sines and cosines of all these numbers. Yeah, the fish scanning. I was doing a lot of things with circles and rectangles and stuff. I'm just trying to... Every piece of information either increases the known convex space or decreases it. And then you like have to take the average middle point and say, okay, that's probably where the fish is. So we want like a pause. Okay. We only really need. I mean, we don't actually need to do any additional subtraction. We do need equality, I suppose, but everything else. I suppose we'll probably want to hash. Do we want to compute distance? Not really. We're using the tube network to compute distance. So yeah, we don't actually need to compute Euclidean distance. You could use it as an approximation. Worry about that later. Oh, we may actually end up using dot products. We can add it later. Okay, so that's set up there. Now, so when at the beginning of the month, we create a new fresh city class. City equals city. So you need to define everything now. Thing is though, the only thing we really need to define right now is the resources. Everything else will be empty by default, which is correct. So after we get the resources, we can say city equals city just empty dictionary resources empty set. Okay, so there's our city. Okay, so for travel routes, if capacity is 0, this means it's a teleporter route. So we want to say city.teleporters add, so this goes from 1 to 2. B. No. Tuple int. I think when you say this, I think it means it's specifying exactly what is in. Okay, so if we do int, that's 2 ints. Oh, okay. I don't really know what these square brackets really mean. I should look that up one day. But so for tubes, you actually want int, ID capacity. You don't need to do this, but it helps us get it right. And just looking at this, it gives you an idea of what kind of structure it's gonna have. And if you're writing a proper piece of software, then you should do this. Like you want everything to be correct. You don't want people throwing random crap into your city, which isn't of the correct type, because Python will let you throw random crap of different types into the city. You can't do that with C++. Well, maybe you can, I don't know, but Python you can put strings and numbers and whatever you want, video files into one big list. So that's else it's a tube. So we want to say similar to this. Oops. I'm going to say tubes dot add. So go building 1, building 2, and we want to add the capacity. However, we also have to add the opposite direction because these are bidirectional. Okay. So that's resources, that's routes, then we've got pods. Well, suppose we just store this with the city. Pods is just like buildings. It's a dict from an int to a pod. Pod properties is input. Okay. We have to do some parsing here. We could do this. So it's going to be it's going to look like this. No, one place. Space separated integers. So let's do int x or x in input dot split on the spaces, put them all to ints. So the first will be the ID none. So we've got basically a pod, which has the first property as the ID num, and then the path is going to be, okay, in this case, oops, music stopped. Get rid of this because it's not one int. All right, so num stops. Okay, we don't need to check this. We can just say it's going to be pod properties on 2 onwards. 2 onwards will be the list of the path. Yeah. Say this is a tuple or whatever. Or a list. Save on characters. Pass that to a tuple. Alright, so that's pods. Num new buildings. Okay, so the only issue here is we do actually have to remember all the old buildings. Now, this is where we create the new city. So we could say, when we add the buildings to the city, we could actually just pass in the old buildings like this. This won't work on the first turn though, because there was never a city to begin with. So the correct thing to do, we say if first turn for empty dictionary, otherwise blah blah blah. But we can do a hack here and just say, I don't know, city equals city, so that there exists something to begin with. City equals arguments. Oh, you actually need to give it arguments. All right, we'll do it the correct way. So this is like wild true. So instead of wild true, this should be for month in what are the numbers we have here? 20 lunar months of 20 days each. Okay, so month in range 20. Hopefully that's correct. So it's going to be so it's going to be an empty dictionary if month equals 0, else city dot. Otherwise, copy forward all the old buildings. Pods? Yeah, okay. Pods is... But wait, we need to copy forward the pods as well. Oh, we have to copy forward everything. No. So this tells us all the routes, including old routes. So it doesn't tell us... Okay, so we don't need to copy forward routes, teleporters, tubes, pods? Pods? No, it gives us all the pods. Okay, fine. So we only actually needed to copy the buildings. I suppose because that's not something we made, that's something the game made. It doesn't like the fact that city may not have been declared before. It's fine. Okay, and then here's where we add the new buildings. So I guess we want it roughly the same as this. Is it going to be inside? I don't know. Let's have a look. Excuse me. New buildings. Okay. So it's got coordinates. Number of astronauts, and then... Okay. So, city.buildings. So the ID number will be... Hello, Brad. Welcome in. Yeah, it's another season. Well, we usually only get 2 a year. Seems interesting. There's a lot of information to process here, but it doesn't actually look that as complex as the AI ones. Simply because you don't need to write any AI. It's more of a heuristics and optimization stuff. Yeah, I think I've been streaming just over an hour. This isn't going to be a long one, so I think once I've finally processed all the input and maybe try and get a submission which actually succeeds. I think the most basic thing I can think of is for every pair of buildings, I don't know, just try and build a tube, a bidirectional tube. And then try to upgrade all the existing ones. So every time we try to create one by one and it already exists, the game won't let us, but it won't error. So it could just literally just go through all the different routes, try and build a tube, and then try to upgrade them all, and it won't error if we try to upgrade an invalid tube. That's fine. So if I just write that loop, build every possible tube, upgrade every possible tube, I think that should be safe instead of whatever this is. And then I think in most cases it should actually get us points, because eventually it will get at least one astronaut to their destination, you would think. So we can try and do that. Buildings. So this first number here is the module type. It is all inst though. Alright, so we'll add one more into the building, which is the module type. So Brad, are you doing this too? So for now it'll be like 0 means landing, but we don't have to worry too much about that. And then say so the ID num will be this should be building properties. So the ID num will be building properties 1. That's the ID num. Equals a new building. So it'll be that again. Module type will be the first. Let's maximize this. And then we want the pos, which will be basically the x, y, which is 0, 1, 2, and 3. Then we want the list of the astronaut types. So that's just going to be 4 onwards. 5 onwards. The first number actually just says how many astronauts. So it'll be 5 onwards. We'll want to cast it to a tuple. 5 onwards. Okay, and that should just sort itself out. That's it. We've processed the input, I think. Let's get rid of... Alright, we'll just do nothing for now. Because that's actually technically safer than whatever that was. Let's just make sure it kind of runs, but we won't get any points. So that actually fails because you have to get a point to pass. Okay. Alright. So, what should we do? So I think we want to... So the city contains the buildings, the resources, the total pods. So we basically want a decide method. Given the city, we want to decide what to do. So for now, we don't need to make all the print methods. We'll just say we'll build tubes at every possible pair of buildings. So but we need to append them. We need to do one print statement, don't we? It doesn't matter how long it is, does it? Separated by semicolons, okay. So for now, let's just say, hello Galvabot. So just started with this. Yep, just started now. I'm about to try and write the most basic program that might get points. Just finish processing the input. And that's probably where I'll stop the stream. I only intended it to be a starting stream. So the problem looks so complicated. I haven't understood it yet completely. Yeah, there's a lot to take in. Because we don't have the leagues, the wood league, the bronze, silver, it doesn't progressively take you through the rules one by one as they introduce new things, so you do get thrust into the deep end pretty quickly. So right now I'm going to just try and build a tube between every possible pair of buildings, in no particular order. Because if you don't have the resources, or if there's already a tube there, that's fine. The game doesn't error, it just doesn't let you build it. So let's say for building 1 in city.buildings.keys, so that's for B2 city.buildings.keys. If B1 not equal to B2, well, we're going to have to orders equals a list of strings that we're going to have to tie up with semicolons. Then we'll just do orders dot append what was that? Network error. I need to force myself to use these F strings. I keep going back to the old dot format method. How do I do it again? It's F something. I need to look this up again. Python F strings. Like, right, that's the old. These are the old ways. Just tell me the new way. No, that's okay. That's the newish way, but tell me the new way. Like that. And then you've got the variables. Okay. So it's orders.append F. Just stick to single quotes. So it's going to be tube. Building 1, building 2. Got it. All right, so it's going to be. So you want to put the B1, and that will cost B2. Okay. And then finally, if there are no orders, print wait. Else print just join them all up with semicolons. Order doesn't actually matter, but it will do it in the order we did it. try that. Did not get any orders. Building 1, building 2. We don't have any buildings. No, we have buildings. We don't have them in our list. Why didn't we get the buildings? So we'll reach these on turn 1. These should appear in new buildings, right? City.building. So let's log city.buildings. Oh, that's why we're not doing anything. Because we're just printing weight. I need to call this side city. Let's do that. Okay, so we're trying to build the same things over and over again. That's fine. Why does no one want to take the tubes? Because we didn't put any pods. You gotta put pods in. Right, how does that work? So after we placed tubes, so that's city parsing. Okay. Improvements. So we build tubes. So we've just built tubes in every possible place. You can upgrade. We could do that. Building pods costs 1,000 resources. So create a pod and you define its par. So let's just make pods between, just on a basic par. Okay, so when we... It's cost 1,000 resources. Is that a lot? I don't know. I have no sense of the numbers here in terms of resources. So let's build a pod. Like, okay, so we build a tube. And then let's also, if we have the resources, try to build a pod right there. So only build a pod on the tube that we've built. So we do... So we'll do pod. The pod identifier must be included between 1 and 500. We decide the ID. Does it matter if we give all the pods the same ID? Is it gonna complain? Let's just try and give them all the same ID for now. Give them all ID 1. If the last stop is the same as the first, it will loop around. So we actually want it to go back and forth, don't we? So we'll do this. Go back to P1. Doing that costs 1,000. Building a tube costs basically the length divided by 10. What kind of lengths are we talking about here? So that's like 80, 60. These are very small lengths, so building tubes is not that costly. Building teleporters costs 1,000. So I would say after we've done that, and we've done all of that. Hang on, so how much is a pod? Wait, how much is a teleporter? That costs 5,000. Alright, let's try this. We're building tubes and pods. I don't think it's going to like them all having the same ID number, though. But then, does that mean there's a maximum of 500 pods? I guess so. Use another ID. Okay, fine. So we need... So we have pod ID num equals 1. Then we have to do... Or... No. Let's do this a bit more correct. Get pod ID for x in count 1. So this will just count infinitely from 1. Yield x. This needs to be imported from collections import count. Capital C. No, it's items, isn't it? It's lower C. Okay. Let's just do that. Like that. So when we get past 500, that's it. We can't really make any more pods. So we'll keep placing pods. Fine. Let's try that now. Invalid integer value in pod yield x in. So x is not an int. Oh wait, what does count to? Maybe it is capital. No, gotta look this up. Tools count. I think I'm using it correctly, aren't I in count and print I. Oh. Yield x. Start. Am I not supposed to? Do I need to say start equals 1? Generator object. What? Well, X in count. So this is a generator, but X should be an int. Shouldn't it? Count 10, 10, 11, 12. Yeah, look, that's so... Um... I'm lost. If I did 4x in count, they should just give me 10, then 11, then 12. Shouldn't it? Oh no. Have I... No. No, that's right. I did put the brackets. If I took those brackets away, that would be the method. Okay. Generator object get pod ID. Do I need a, I don't know, like a return statement at some point? But it would never reach that anyway. Using itertools count to generate new IDs. Yeah. One of the classes using itertools to generate incrementing ID. This is what I want. Okay. Well, it's... Let's go back to the geeks for geeks. I don't know. Just create count from scratch, but just log x and we'll see what we're seeing here. That should be an int. don't think... Oh, you don't call it like this. You do... Oh, this is not how you... This is not what you don't call it like that. This starts the method. You want Oh, I've completely forgotten Python. No, you don't do it like this. So this method is correct. Next. I've forgotten these basic things. Python. Use generators to get next available ID number. Just look up. Yep. I've forgotten how to use generators. Okay, we're doing that basically. Num equals 0, large will yield num plus 1. Okay, now how do we call it? You would say, like, for x in infinite sequence, but we're not doing that here. You would, of course, we can do dot next. Okay, I remember now. And I was using this for one of the Advent of Code problems pretty heavily, because that month, that year, had a lot of these like computer simulation problems where you had to iterate the steps of computer, but keep pausing the computer. So it was really heavy on the generators. You have to say... So let's say call this pod ID generator, and then you have to say pod ID equals that, and then here you do that dot next, because what I was trying to do there was just calling it fresh every time. This is the static reference to the generator which is in progress, and then no, not dot next like that, or no, it's next as a like that. Okay. Yeah, because that what I did didn't make sense, because there's nothing stays the same between the different calls. This looks like the problem here though is that we're spending all our resources on that one line, because it always does the first one. Which makes sense, because we're always going in that order. Let's just see if it actually passes all test cases. You should get a point, at least. The problem is it could get trapped in a line that no one ever uses, and it would just keep upgrading it. Balancing is going to be bad, but if we get a single point, we're fine. Our villages is where we failed before, so let's see. If we pass this... Oh, we failed this. Time out? How can we time out? Timed out in the first turn. I think because we have a quadratic number of tubes, so we're writing too many of these statements. Yeah, this is too long. So do we want to just cap it at like... just the first... What's reasonable? The first 100? Even that might be too much. I don't know. They don't... No, it's not because this string is too long. It's because our code is timing out. Oh, no, we just didn't get any points. Alright, how about we don't... Okay, this is wasting money. We shouldn't add a pod. If there's already a pod on a line, we don't add a pod. So let's just make this a bit better. So that means if... So we need to see if... So a pod has a path. Okay. We'll just have to do a linear search through all the pods. For pod in city.buildings.pods. Dot values. That gets the actual pods. So for a given pod, if its path, if pod.path is the same as or is either, it's either B1, B2, B1, or the other way around. B2, B1, B2. Then break, because that pod, no, continue. Then we've found a pod that's already on this path, so break. Else, if we've exhausted that list and not found any pod on this tube, then we try to build a pod right here. And we don't need to do this, maybe. Alright, so now we only build a pod if there's no pod on that line. That would save so much money because we're just kind of placing pods that probably aren't getting used. Actually, for a comma. Train orders. Oh, I don't need those at all. Dict object is no attribute pods. Buildings. What am I doing? Okay, hang on. City dot. No. City dot pods, not buildings dot pods. Now we're timing out on the first turn. We also don't want to... Let's optimize this a bit. Buildings, we only go from I+1 onwards. So that we don't need this check here. So that's probably not going to solve it, but that does mean we don't go two different ways. Okay. Alright, what's the problem? Is there still too many of these? Let's cap it. What could be timing out? So this for loop could be... There's quite a lot of buildings. So much for this being a simple solution. It's not, there's too many buildings, so we're trying to count all the possible pairs of these buildings, but some of them are not even sensible links, because these are landing pads. So ideally, you would hook every landing pad up to some building before you start worrying about the inter-building. So let's sort these by... Oh god. How about we just hook up landing pads to non-landing pads? So let's do it like this. Landing pads equals L for L in hang on. City.buildings.values if L dot, so we need the module type to be 0. And the others are, what is the term that's used for the others? Modules? Just call them modules. Modules equals, so I could just say M if L is not equal to 0. All right, now we say for B1 in landing pads. So this will reduce number we go through here. Modules. Try that. L is not defined, but oh, M. And if we're doing it this way, we don't, if quad par equals that, we would never go the other way around. What are resources given for? I think you get resources for getting an astronaut to their location. And you get more depending on how fast you got them there, up to a maximum of 50, and how... Oh, sorry, resources, yeah. That was points. Resources, I don't know where you get resources from. You get interest on whatever resources you hold, but... I don't know. Do you get a fixed income each turn, or? I'm not sure where to look. Wait, how do I search in this menu here? In example 2, you get extra points. Extra... Yeah, I remember the bit about the 10%. So is... I reckon you get a fixed... Let's go from the beginning in. Okay, so that's transportation. This is buildings. So that's points. Okay. This represents the number of resources you have. This costs resources. We could look in the GitHub code, you'd have thought. All unused resources yield a 10% interest, so maybe it is just the interest, but then you say there's more extra resources, I don't know. All we know for now is that they'll tell you what resources you have at the beginning of each turn. Okay. I think I'm just going through too many of these buildings here. Let's just cap it for now. Just the first 10 landing pads, first 10 modules. So that'd be like... Still timing out? Maybe the timeout is not what I think it is. Let's just try the first 2. Oh yeah, I need to replace... In example 2, you get extra resources in the beginning. So it could be that you're just living off the income, I suppose. I don't know. The interest. That mean you have to really need to budget. So this is building1.id num, building2.id num. Okay, so I really had to cut down the number of modules we looked at because it was just too many. Did not score any points, so we added those, and then we're just looking at those again. So we could go for all the landing pads. But not as many modules, I don't know. Just focus on the first 5 modules arbitrarily. What we really should be doing... Okay, so that's interesting. Did not score any points? Really? Is there not at least one astronaut amongst those that wants to get somewhere? Alright. Well, that means we actually have to look deeper at what astronauts actually, where they actually want to go and stuff. Could not create pod. The ID must be between 0 and 500. Oh, because we've reached our pod capacity as well. Ah, because this, whenever it fails, we're still generating a new ID. So we do need to check if that tube actually exists. Alright, I've got a better idea. We don't want to generate ID nums like this. Instead, we want so when we create the pods, we know what ID numbers are left. So we can just say available pod IDs equals set range from 0 up to and including 500. No, it's actually going to be 1 up to and including 500. Okay. And then whenever we encounter a pod, we just say remove that ID. Then we know exactly what is available. And then we say here new pod ID equals dot pop, You can do that for a sec. Okay. Do that. That will ensure it might be empty though. If available pods IDs, then we do this. Okay, try that. There is no tube between buildings 0 and 8. Yeah, because we need to check if things actually exist. Did not score any points, really? Are we just not... We're just not good. Just not good. I would have thought by chance that should score some points. There's so many different buildings, that's the problem. So lots of astronauts who arrive probably want to go to... specific places like 10 and 12, but we're not connecting to the right ones. Timeout. We don't want a timeout, so we'll just stick with. Can we go up to 10? Is that still too much? We can do that, but we don't. Oh, we time out. All right, it's too much. Just see what the point. Okay, we do up to 8, I guess. We don't get any points. Try all the other test cases. I think we can still get points for submitting this. It just won't work a lot of the time. But I mean, that's the point of these. These are specially chosen to catch you out, I guess. Ho ho ho! It would make an interesting... We got points there. So we pass all except village. Or no, we haven't seen these ones yet. Okay, we pass grid. That's cool. We should actually try to make it connected. That way there is a route between any two nodes that are on the full network. That's what we should be doing. Not random things, not random pairs of nodes, because those will just be disconnected chains. Come on, distribution network. What happened here? Let's have a look at distribution network. One. So these are. Oh, I see. These are intermediate nodes, but we're just trying to go to them, but not going any further. Yeah. So if we were instead trying to expand our network from the new ones we've added, instead of just trying to hook up all these landing pads to random modules, then we probably would reach these ones eventually. But why would we ever send them here when we could just send them directly to... Does any astronaut ever want to go to these? So we should only be sending them to modules where there exists at least one astronaut wanting to go there. I mean, that would be a huge improvement. And in this scenario, it'll probably hook it up to those directly. If we can afford it to begin with. We might not be able to, but... Alright, let's submit that. I think I'm done for today. There was a lot to think about there. It's quite complex. Computing score. Do we get a non-zero score? Like, if it fails on 2 test cases, then... Oh, you do actually still get points. 83%. We got, like, 1,000,000 points, okay, between the... except for villages and distribution network. I mean, I can see how we can hack the solution so that it actually passes villages and distribution network. I mean, it can't be hard to get a single point. Let's see, where does that put us on the leaderboard? Oh. Wait, what was our points? We're ranked 277? That's way better than I was expecting for a really crappy solution. It's only been a day. 277. We're there. So if we get it to 100%, they've got lower points than us. Ah, so it matters. Your percentage matters. So you should, if you want to be properly ranked, you need 100%. And it's probably not hard to get 100%. I mean, this is just passing these test cases. So once we're in 100%, then we're basically in the proper leaderboard. And from that point, if we were still getting, you know, 1.1 million, we would be like here in the top 200 or so. It's only about 800 people. I don't think there'll be as much interest in this as the bot tournaments because it's not as exciting, but it's an interesting change. Yeah, so you basically need to have 100% on the test cases to be properly ranked. Okay. Alright, well, tomorrow, or I don't know, whenever, we don't have many days, I will try to make sure we get 100% on the test cases, which I think is doable. It's not hard. We can see exactly what we need to be doing on the distribution network. I don't know how much it costs to build a line from here to here, but we would want to do that, and then from there, yeah, village. And we're not even creating teleporters, but yeah, I'm not sure where we're getting resources from. It looks like it's actually just straight up interest on your resources. So you gotta spend wisely. You only want to spend about 10% of your wealth each month. Like 500, say. So that you'll, well, it's not 10%, it's little bit less than 10% to ensure that the 10% you get on what you have left will bring you back to what you had, roughly. I don't know, it depends. But you can afford to spend a bit because that's what gets you points, but... I have a question. If I join the event but not submit anything, would I be ranked? I don't think so. You have to at least click submit once, even if it's broken code that does nothing, to be on a leaderboard. If you just submitted the starter code they gave you, that would still get you ranked, I think. Because it still gets you points. It might get 0 points. You got people here on the leaderboard, so they've clicked submit. In fact, the starter code gets points. So I don't know what these guys have done. I guess they've written... I guess they've bugged it. They've made an error or something, so that'll get you 0. The starter code they give you, if you just click submit, I think you actually get points. So you would get just like a small number of points, so you'd still be on the leaderboard. You'd be ranked, yeah. See, look, a lot of people here have 222995. So I reckon that's what the starter code gives you. They've just clicked submit on the original starter code, and that just happens to get 222995. That must be what happens. So if you write code and it's worse than 222995, then you might as well just stick with the original code. I'm curious about the event, but I don't know if I want to commit to this, and I don't want to get bad placement. I mean, you don't have to worry about bad placement. It's meaningless. So it's only meaningful if you're in the top few hundred or so, because it's known that a lot of people at the bottom of the leaderboard might have written bugs in their code, which is just giving it a flat 0. So it doesn't make you look bad or anything. It is a short amount of time, relatively. We've only got 5 days left. So yeah, I mean, I wouldn't worry about it too much. I would just write some basic code, submit, see what happens. I mean, at the very worst, you can always just submit 222995 code and you'd be in the top, like, 700 out of 800. See, these guys actually get ranked even though they got the same score, so I guess it's whoever got there first. Which is a bit weird, but a lot of people on 222995. So the first person who submitted his starter code, that's already got him into the top 400. Everyone else who did it later, I guess, just gets placed later and later. And that's like basically the top 50% of the league. So if someone had just opened up the event and clicked submit immediately, that would have got them in the top 50%. Oh my god, so the time matters? Well, not really. That's just a weird situation. It's very unlikely you would get the same number of points as anyone else. But that's because they're using the starter code, so I guess it just ranks by time if 2 people draw on the same number of points. But if you write your own code and beat the starter code, which you should be aiming to do, to be honest, then... And it doesn't seem too hard to do, because I've done it this stream, and it seems like I've at least tripled the starter code points. then at least as long as you're beating the starter code, then you would probably not tie with anyone because that's so unlikely. So it doesn't really matter. Time doesn't matter. Anyway, when this competition is over, the whole thing gets re-ranked. So it doesn't actually matter. This is during, and it gets re-ranked with different test cases. So everything you're seeing here is not going to be the final score. It's just kind of an indication of where you would be roughly. But when the competition's over, it'll be re-ranked. So at that point, the time submitted shouldn't matter because everybody gets re-ranked at the same time. So so yeah, time doesn't matter. It does matter for the live leaderboard, but this isn't going to be the final leaderboard. It'll be a new leaderboard with secret test cases we don't know. But yeah, if you passing the test cases is going to get you into the top 200. And it doesn't seem like it's too hard to pass the test cases. You just got to get a single point to be able to pass the test cases. And you can get a single point by just finding one astronaut who wants to get somewhere and build a tube between his place and that place, and that will get you a single point, right? And if you could just do that, you would get 100% on the test cases, and then that should get you in the top 200. It just wouldn't get you good points, but the percentage is actually the primary ranking criteria. So you need to get 100%. So yeah, if you do that, if you just send one astronaut to his destination, you'd get 1 point and you'd get 100%, and you'd immediately be in the top 200. So you could do that. Out of all the people who have passed the test cases, the lowest score is that, which is very low. So, all right, I think we're done for today. Probably gonna go play some video games now. Let me see if I might join the event, then thanks for the info. Yep, no problem. No one else is streaming this, so I guess, unless I check on Twitch directly, but I don't think. CodinGame. It's just me. All right. In that case, I will. Let me just check if there's anyone I actually want to stream that's doing something even remotely programming related. A lot of people playing Satisfactory because Satisfactory just launched, and I'm probably going to play that later on. Doesn't matter. All right, thanks for watching, and I will carry on with this. Probably not tomorrow, maybe the day after. I've only got 5 days, so I can only afford a couple of 2 or 3 streams probably. I'm not going to aim for a high score, but I will, at the minimum, get the test cases 100%ed, because that's important. All right, thank you for watching. Bye-bye.